This is the second video. In this video, we'll be finding the inverse functions for several different given functions. Okay, in the 6th edition book, this is 2.7, the second part of 2.7. In the 5th edition, it's 3.7. Okay, in the last one, when we talked about inverse functions, if you remember, what we found that you had to do to get the inverse is you had to switch x and y, and that's what we did on the graph. Well, the same thing happens when we're looking at the equation. So remember that f of x is really just another name for y. Okay, so I have this equation, y equals 5x plus 1, right? So I want to just switch the x and the y, right? So now I've got x equals 5y plus 1. I just switched places, x and y. And now I just need to write it in function form. Okay? That means I'm going to solve for y. So first I'll subtract 1. And I'll divide by 5. Okay, so that is what y is equal to. Now, so whereas the first function was called f of x, we call this the inverse of f, and that we write it f with a little -1. That means the inverse of f of x. And I would write that as x minus 1 over 5. Or you could do x over 5 minus 1/5. All those would be a fine way to do it. Okay, let's try another one. All right, so let's do how about the cubed root of 2x plus 3 minus 1. Okay. So the first thing we need to do is switch the x and the y. And remember, this is really a y, right? So now we have x equals the cubed root of 2y plus 3 minus 1. And now we just need to solve for y. So we have to get the cubed root by itself first, so we'll add 1. And then we would cube both sides. And now we just keep going. We'll subtract 3. I'll come writing it up here. And divide by 2. And there we have it. So we would write that answer as g inverse. So g to the -1. It's that little -1. It's not really an exponent like we use exponents. It's not to the -1 power. It's not 1 over g. It's the inverse of g. All right? And that inverse looks like that. And that's a good function, right? That's a function. So they are both one-to-one functions. That's the inverse. Okay, so here's one that's a little bit harder, because if you notice, there are 2 x's in here, right? And we are going to switch, same as before. We want to switch x and y. So we're going to be working with x equals y minus 1 over y minus 2. And I have to solve for y. So you might start thinking, well, I got 2 y's. What am I going to do? Well, it's just the same as when we had x's or something, right? If we have two variables, two y's, and we're solving for that variable, then we have to try to get them all together on the same side, right? So the first thing you'd want to do is multiply by this whole denominator, right? So we'd have x times y minus 2 equals y minus 1. And that gets our y out of the denominator. So that's the first thing. We have to have it out of the denominator. And now, if I'm going to add y's together, I better have them in separate terms. They can't be inside this parenthesis. So let's distribute. So that would be xy minus 2x equals y minus 1. All right. And now remember, you have to keep reminding yourself, I'm solving for y, so I got to get the y's together. The x's are just like anything else. I'm not solving for x, so I'm going to put those on the other side. I just want the terms with y. So I'll put all these terms with y. I'll subtract the y, and then I'll add 2x to the other side. Okay, so now I've moved the y's, the two terms that have y's, I moved them on the same side, and I moved the other stuff to the other side. So now, it may seem strange to you because we're not used to seeing it with this other variable, but if you had 5x minus 2x and you were solving for x, you just combine them, right? Well, what we're really doing when we combine them is it's like we're going to factor out that y, and whatever's in front of them, that's what will be added together. So that works here. We factor out the y, and we're left with x minus 1. That's the only thing we did. But now, do you see what happened? I got my y by itself. So now we'll divide by x minus 1. Right? So I've got y, or that is inverse of h, is equal to 2x minus 1 over x minus 1. And that's a function, right? That's a good function. And so I know that the other one was a function, a one-to-one function as well. All right, here's another equation of a function. F of x equals the square root of x minus 2. So let's think about this for a minute. Remember, this is going to be a square root that's going to be reflected up to be a square function. So you know that if we were to sketch a graph, it would be shifted over 2, right? And then it would look like that with the our square root function. So if when we reflect it, you know, we're going to only be able to use part of our parabola. We're going to have to restrict the domain. So we'll use our graph to help us figure out the domain. So in the meantime, let's switch the x and y. Square root y minus 2. We'll square both sides. And then add the 2 to solve for y. Right, so we have that f inverse is x squared plus 2, right? So that would be up here. But this is our endpoint, right? And that's at 2, 0. So at 0, 2, that's our vertex. Okay? And we only want to use this part, the part where x is greater than or equal to 0. So that's how we would write our answer. f inverse equals x squared plus 2, but x is greater than or equal to 0. Okay, so we include the restriction on the domain when we have to write an answer like that. Okay, there are 2 questions. Since this is the only one for today, and I figured I would keep with 5 questions per quiz to make it worth the same 5 points. There are 2 questions for this video. One is to find the inverse for f of x, which is 2 minus 5x, and the other is to find the inverse for g of x, which is 3x minus 1 all cubed plus 1. So write those down and solve them and put them into the quiz on Canvas.